Imagine for a moment that everything you've ever learned about reality, I mean, from the smallest particles that make up your hand, all the way out to the vast, swirling galaxies light years away, wasn't really the full story. What if it was all built on, a set of assumptions, and there was a profoundly different, maybe more dynamic, and deeply interconnected explanation just waiting to be discovered?
Hmm.
Well, today, that's exactly where we're headed. We're embarking on a really deep dive into precisely that kind of revolutionary framework, the Unified Coherence Theory, or UCT, developed by Philip Randolph Lillian. Our mission today is to truly unpack its, well, audacious claims, understand its foundational concepts, and explore how it offers this cohesive path from what it calls omnilectic invariance. It sounds complex, but it's essentially a state of pure, undifferentiated potential before anything really takes on a distinct form.
Right before the structures emerge.
Exactly. All the way from that state to particle physics, the grand scale of the cosmos, and maybe even the very nature of consciousness itself.
And we've been digging deep into a foundational overview paper and quite extensive discussions about this groundbreaking idea. So what you're about to hear is essentially a fast track, a shortcut to understanding an idea that, if it holds water, could genuinely flip our understanding of reality right on its head. It's incredibly ambitious, really comprehensive, and it seeks to bridge these gaps that traditional physics has, frankly, struggled with for decades.
That is a bold promise. And UCT definitely wastes no time making some big claims, especially by challenging some, let's say, long-held traditions in physics. So maybe let's start right there. The radical departure UCT represents.
Okay, so when we think about physics trying to unify the fundamental forces, find that grand underlying theory of everything. A common approach has always been to try and identify some irreducible fundamental building block. Think about things like point particles, or maybe tiny vibrating strings, or sometimes even specific geometric shapes. These are usually just assumed, right? They're postulated as the starting primitives, the absolute basics from which everything else is built. Yeah, it's like saying, here are the Lego bricks, now go build the universe. That's a great analogy.
Right.
And take, for instance, an idea that our sources mention as a good point of contrast, something called tetraionic theory. It's fascinating, though ultimately challenged by UCT's perspective. Tetraionics proposes a very specific primitive, the equilateral triangle. It calls this the Planck quantum. The idea is that energy itself exists in these sort of quantized, flat, triangular forms.
A triangle as the fundamental unit of energy.
That's the idea. And it tries to assign charge and mass relationships directly to the geometry of this triangle. It suggests this inherent, almost visual elegance in how the universe might be put together from these simple, fixed shapes. It even makes a distinction between, 2D mass energy, which it sees as these planar energy fields, and 3D matter, described as standing wave structures formed from these triangles. The whole claim is that the geometric arrangement could account for electrical charge, EM interactions, trying to give a structural explanation for forces and unify QM, EM, and GR under one geometric roof.
Okay, I can see the appeal there. It sounds neat trying to build everything from one simple shape. But if that's the kind of traditional approach, what's the fundamental flaw from UCT's perspective? Because UCT critiques these static primitives pretty hard, doesn't it?
Oh, absolutely. And the core critique from UCT is, well, it's profound. These postulates, like a fixed equilateral triangle, fundamentally lack dynamism. They just sit there. They don't offer an inherent reason, an ontological explanation for why that specific shape should be the fundamental thing in the first place. And maybe more importantly, they don't explain how this static thing emerges from deeper field principles.
Yeah.
The geometry is just seen as static mechanical. It's not an evolving consequence of something deeper and more fluid.
So it's like saying, here's a brick, but you never explain how the brick itself was formed from the clay in the fire or how it even became rigid. It just is a brick.
That's a perfect way to put it. And beyond that, tetraionics, at least in UCT's view, simply lacks an underlying coherence principle. UCT posits that this coherence field is the essential dynamic substrate, the very stuff from which all structure, all force, and all matter ultimately emerge. Geometry alone, no matter how elegant it looks, just cannot account for the fluidity, the interactions, the system behavior we see without this field-driven modulation.
So the static nature just doesn't capture the interconnectedness, the constant change.
Exactly. It doesn't capture the flux that UCT sees as absolutely fundamental.
It sounds like there's this issue of assumption versus emergence, too. Tetraionics just assumes the triangle exists, but UCT is saying these shapes are actually consequences of something deeper.
Absolutely spot on. Tetraionic assumes triangles maybe because they tile space nicely or they fit certain quantized models. It's a pragmatic assumption, you could say. But in UCT, triangles and tetrahedrons aren't assumptions. They arise from deep symmetry constraints and field resonance within this coherence field. They are consequences, they're outputs, not starting points.
So the form follows the coherence field, not the other way around.
Precisely. And that difference in causality is crucial. UCT aims to be a generative theory, showing how forms come to be, rather than just a descriptive one that states what forms are.
Okay, and what about the specifics of that Planck triangle idea itself? Are there other problems UCT points out, beyond just the general lack of dynamism?
Yeah, there are a few pretty significant issues when you look closely from the UCT perspective. First, this idea of putting charge on a fundamental geometry, implying, one side is positive, one negative, one neutral, right at the most fundamental scale. Well, that suggests a kind of arbitrary directional bias. It's a bit of a strange assumption, having local polarity without any underlying field dynamics causing it.
It's like the charge is just painted on.
Pretty much. It implies geometry precedes field structure and charge. But in UCT, that's reversing cause and effect. Charge emerges from dynamic coherence, asymmetry gradients, things related to chirality, or spinor bifurcation, or boundary tension in the field. You don't need to arbitrarily embed polarity onto a static shape. It comes out of the dynamic relationships within the field itself.
Okay, that makes sense.
Second, there's the equilateral uniformity assumption. Equilateral triangles are perfectly symmetric, rigid things. But the quantum world we actually observe is anything but rigid.
Right, it's fuzzy, probabilistic.
Exactly. Real quantum dynamics, subquantum dynamics, they seem to require asymmetric perturbation, vibration, curvature. UCT's model allows its structures, which can be triangle-like or tetrahedral, to flex, fold, resonate like dynamic field expressions, ripples in a pond that can change shape. Not just static blocks. Tetraionics struggles to explain how a rigid triangle accounts for the inherent fuzziness and constant flux of quantum reality.
And the third point.
And finally, tetraionics seems to offer no real account of dimensional embedding or how higher-order structures emerge. It doesn't explain how these simple 2D triangles embed into higher dimensions, or how they interact with space-time curvature, or the emergence of mass, or even the direction of time. In contrast, UCT develops concepts like hyperfractal layering, multi-vector time coherence, dimensional emergence via symmetry reduction, things you just can't easily derive from simply tiling static triangles.
It sounds like trying to build a complex symphony using only a single unchanging triangle wave. It just lacks the necessary dynamics.
A great analogy. It fundamentally lacks the dynamics and the resonance layering needed for a complex reality. So yeah, UCT views tetraionic theory more as a kind of geometric metaphor, maybe visually appealing, but not a truly dynamic ontological framework. It lacks the field logic, the coherent gradients, the dimensional emergence, the observer integration.
It's a pretty picture, but too simple.
Too simple to account for the richness, yeah. That's the UCT critique.
Okay, so if we're moving away from these static assumed primitives, what does UCT propose instead? What's this dynamic ontology really all about? How does it actually generate reality?
Right. So UCT's core innovation is really profound. It replaces those static primitives with a dynamic coherence field ontology. In this framework, nothing is fixed in the way a triangle or a point particle is just assumed to be fixed. Instead, things like geometry, mass, charge, time, even dimensionality itself, they are all emergent consequences. They arise from what UCT calls coherence gradients and symmetry reductions happening within this vast dynamic field.
So it's less like building with Lego blocks.
And much more like watching a crystal grow from a solution, or seeing a complex biological system unfold from a very simple set of rules. The structure emerges dynamically.
So the universe isn't just there or built, it's grown, it unfolds.
Precisely. That's a fantastic way to think about it. And this coherence field isn't passive, it's not just sitting there. It's actively governed by what UCT calls generative operators, specifically the 6 fundamental asymmetries. Now, these aren't just labels, they act like the universe's foundational dial settings or fundamental switches. Each one influences a different aspect of reality, whether something spins left or right, whether it has mass, how time flows. They are the active agents producing gauge symmetries, field interactions, the very fabric of spacetime.
Okay, the six fundamental asymmetries.
Yeah, okay.
And this sounds like where the coherence bubbles come in, which you mentioned earlier. How do they fit into this dynamic picture?
Yes, exactly. The theory introduces coherence bubbles as a really crucial component. Now, these aren't particles in the way we usually think of them. They're described as bosonic field condensates. Imagine them as localized, self-organizing whirlpools or resonant pockets of energy within this vast coherence field. They represent quantized units of vacuum curvature and symmetry structure, like stable ripples or standing waves, but much more complex.
Okay.
These bubbles interact according to a newly formalized coherence bubble group algebra, and their interactions actually give rise to dimensional layering through a process UCT calls hyperfractal emergence. And this elegant approach, starting from just the coherence field and its asymmetries, allows for the direct derivation of the SU2 and U1 gauge groups, the ones governing the strong, weak, and electromagnetic forces, without ever having to just assume their existence as separate entities. It's all emergent.
That's a massive claim. Deriving the fundamental forces. And the scope of this theory isn't just limited to particle physics, is it? It seems to reach into areas traditionally considered quite separate from physics.
Not at all. That's one of its most striking features. Because it starts from this fundamental field of coherence, it naturally integrates concepts that physics usually struggles with, like biological coherence, observer effects, and even the ontology of consciousness itself. It's truly aiming for a model of reality that encompasses everything, from the tiniest quantum fluctuation all the way up to the nature of our perception. It suggests consciousness isn't some weird afterthought or byproduct, but potentially an intrinsic aspect of how reality manifests.
Hey, this is where UCT gets really fascinating and, well, incredibly ambitious. You mentioned these six fundamental asymmetries as the generative operators of reality, these universal dial settings. Can you define what they are and what role each one plays in literally shaping everything we know?
Absolutely. These six fundamental asymmetries are the core operator set. And it's important to stress, UCT argues they are not arbitrary. They're seen as resonant reductions of a full hypersymmetry emerging from a deeper, more unified state of pure potential. They manifest as operators or fundamental distinctions really at every level of reality, from how the coherence field bifurcates down to distinctions we see in particles. Let's try and break them down one by one. First, we have chiral asymmetry, represented as such. Think of this as the universe's fundamental handedness switch. It's the operator responsible for left-right distinctions, or spin bifurcation.
Like left-handed neutrinos.
Exactly. It's the source of helicity and weak parity violation. It influences the specific spin and orientation of fundamental interactions. Without it, everything might be perfectly mirror-symmetric, but this asymmetry allows for crucial differentiation.
Okay, one down.
Next up is charge asymmetry, Q. This defines fundamental coherence polarity. It's the generative force behind charge and anti-charge fields, introducing that positive versus negative distinction we see everywhere: protons, electrons, the structure of matter. It's what allows for attraction and repulsion, fundamentally.
Got it. Charge.
Then there's temporal asymmetry. This is the temporal phase direction operator. It's what gives time its flow, its directionality. It selects the orientation of time vectors, essentially defining the phase flow of coherence and giving rise to what we perceive as the unidirectional arrow of time.
So without this, time wouldn't necessarily move forward.
That's the implication, yes. It sets the rhythm, the direction.
Of course.
The fourth is dimensional asymmetry, D, described as the dimensional fold operator. Now, this one is incredibly fascinating because it controls the very emergence of curved or extended space. It's the mechanism behind coherence contraction versus expansion, effectively giving rise to our spatial dimensions.
Wow. So it unfolds space.
It's the operator that allows, conceptually, a single point of coherence potential to unfold into a vast three-dimensional universe, and maybe even higher dimensions. It's fundamental to structure formation.
Okay.
Fifth is mass asymmetry, MIM, which acts as the coherence condensation operator. This governs mass energy localization. It dictates how pure energy concentrations, fluctuations in the field, can condense into what we perceive as mass. And crucially, in UCT, mass is derived directly from vacuum curvature via this operator. It's not an independent property tacked on. A perfectly uniform coherence field would be massless. Mass arises when that field begins to curve and localize under the action of MIM.
Mass from curvature.
Okay, and the last one.
And finally, observer asymmetry, OE. Now, this is perhaps one of the most radical departures from conventional physics. It's described as the internal versus external modulator. It creates the fundamental split between coherence as subject and coherence as object. It essentially links the observer, or the act of observation, directly to the formation and manifestation of reality and measurement. So it's not just about disturbing things by measuring them.
It goes deeper than that. It implies the observer plays an active, constitutive role in how reality presents itself, how potential collapses into actuality. It challenges the idea of a purely objective, observer-independent universe right at its root.
It's a lot to process. It really sounds like a deeply interconnected system where these fundamental dial settings are responsible for literally everything. But, okay, this raises an important question. Our sources mention two distinct yet complementary routes to get to these 6 asymmetries. Can you clarify that? How do both of these pathways lead to the same set of 6 fundamental operators? It feels like we're maybe approaching the same destination, but from different directions.
You're right to pick up on that critical distinction. They are indeed two different complementary ways to conceptualize how this full set of 6 asymmetries can emerge from a deeper, unified potential. They aren't the same thing, but they work together perfectly. The first route is what UCT calls the isotriangle reduction, which gives rise to what it terms geometric asymmetries. This approach starts with a fundamental triadic structure within the field. Maybe think of a basic 3-part relationship or resonance. In this kind of model, you always seem to have 2 elements that are symmetric and one that represents an asymmetric deviation. From this basic 2 versus 1 configuration, 3 primary asymmetries naturally emerge. These tend to be structural, internal to the field, related to fundamental bifurcations or imbalances of coherence, depending on which aspect deviates from perfect resonance.
And which ones come from this route?
This pathway gives us chirality, charge, and dimensional fold asymmetry. These are tied to intrinsic imbalances or differentiations within the field itself.
Okay, that's 3. What's the second route?
The second route involves the S permutation group. This refers to the full symmetric group of 3 elements, which mathematically has 6 total permutations, or ways to rearrange 3 things. Think of it like this. 3 of these permutations are considered even, analogous to rotations, which preserve parity or orientation. The other 3 are odd, more like reflections or flips, which invert symmetry. These permutations are linked to generating effects like parity inversions, observer-dependent orientation shifts, how things look depending on the observer, and temporal flow differences. And this pathway gives us the other 3: temporal phase, observer modulation, and mass coherence asymmetry. These are more about the symmetric or transformational aspects of coherence, how it can be reordered, transformed, or perceived.
So both routes give 6 asymmetries, but they describe different kinds of asymmetry. One set is more structural, the other more transformational.
Exactly, and the full picture, the full 6-fold reduction of that deep hypersymmetry into both observable distinctions and internal operators occurs when both types of asymmetries are active and interacting within the coherence field. It's the complete picture, showing how reality differentiates itself structurally and transformationally from that deeper symmetrical origin.
And these aren't just abstract concepts floating around. They form a mathematical foundation, an algebra, defining how they interact and evolve, right? Tell us a bit about the coherence asymmetry algebra, conceptually at least.
Yes, this is where the theory aims for mathematical precision, though we'll definitely stick to the conceptual implications here. These 6 operators form what's called a coherence asymmetry algebra, CAA. It's a graded algebra, meaning it has structure. And these operators act on the fundamental vacuum coherence field, let's call it AGEL. This algebra defines the rules how these operators transform the field and interact with each other, describing the rules by which reality unfolds. Within this algebra, we have what UCT calls key commutation relations. These describe symmetry-preserving field flows. Imagine a dance where certain partners can move together smoothly without tripping each other up. For example, UCT states that chirality and charge Q commute QC0. Conceptually, this means they are orthogonal. They don't directly interfere with each other's fundamental flow in a symmetry-preserving way. In another key example, temporal phase and dimensional expansion, a conjugate, like position and momentum in quantum mechanics data, they are intrinsically linked and affect each other dynamically reciprocally. Changes in time flow are linked to changes in spatial unfolding.
Okay, so some work together smoothly, some are linked in opposition almost. What about the other type of relation?
Then there are the key anti-commutation relations. These describe asymmetry activations and coherence bifurcations. These are more like the triggers for discrete asymmetry states, where something fundamentally new is created or defined, where symmetry is broken. For instance, one relation suggests the observer function, acting with chirality, can collapse chiral ambiguity to a definite parity state, linking to Dirac matrices conceptually. This implies observation plays a direct role in defining fundamental left-right distinctions in reality. Another relation shows a fundamental tension or interplay between charge, Q, and mass coherence, A at Q, where μ is some structural constant. This reveals how these two properties are deeply intertwined in their emergence. And fascinatingly, the observer, acting with mass coherence, can induce local coherence condensation, This further cements the observer's active role in manifesting localized mass or reality.
So the math describes these fundamental interactions.
Exactly. These relations are expressed mathematically, but their real power is showing the interconnected dynamic nature of these fundamental operators. They aren't independent. They're part of a complex web of interactions.
And how does this relate to the vacuum field itself?
These operators, with all their intricate relationships, are then embedded into the vacuum coherence tensor. Think of this tensor as a kind of mathematical map or a multi-dimensional fabric that describes the distribution and state of coherence across spacetime. Crucially, this tensor is actively modulated by the 6 asymmetry operators, and it evolves dynamically according to an equation like Img-Co. This means it's not a static backdrop. It's a living, breathing field that changes and forms reality. This evolution equation conceptually defines the flow of mass, energy, time, and observer interactions throughout the universe, all driven by the coherence current G-Co. So it's a dynamic, interconnected system where every fundamental aspect influences every other.
Okay, so all of this complex underlying algebra and these interacting asymmetries lead us to these things you called coherence bubbles. What are they exactly?
They sound really fundamental, but maybe not in the way we usually think of traditional particles like electrons or quarks.
You're touching on something truly revolutionary in the UCT framework here. A coherence bubble is not a material object in the classical sense. It's not a point particle like the standard model, nor is it even a traditional field excitation like a simple wave. Instead, UCT defines it as a localized phase structure within the coherence field itself. Imagine this vast underlying ocean of coherence potential. A coherence bubble is like a perfectly stable, self-organizing whirlpool, or maybe a resonant standing wave pattern within that ocean. It's defined by its internal symmetry, its curvature, how much it bends the coherence field, and its inherent coherence tension.
So it's a pattern in the field, a self-sustaining, quantized pattern. It's an entirely original way of thinking about the fundamental units of reality. UCT presents it as a topological ontological unit, meaning it has both a shape or structure, topology, and a fundamental existence, ontology. It establishes a coherence-based metric structure and even proposes a kind of pre-quantum logic and a mechanism for dimensional projection. It's a very rich concept. And to give you a sense of its intricate structure, a coherence bubble isn't just a simple blob. It's composed of several critical interlinked elements. First, there's a coherence phase core. This defines the central oscillatory field, often conceptualized like a harmonic or spiral wave at its heart.
The engine of the bubble.
Sort of, yeah, the core rhythm. Second, surrounding this core is a gradient shell. This involves tensional variation in the field, and it determines the bubble's directionality and how it couples externally to other bubbles or fields. Third, a curvature layer. This is crucial because it governs dimensional bending, spatial embedding, or even the gravitational effects associated with the bubble. It's how the bubble interacts with and shapes spacetime.
Okay.
Fourth, a topological envelope, defined by things like Qn, Wn. This encodes its intrinsic quantization, its spin, or a winding number, essentially, its global identity, its flavor, and how it behaves topologically.
Like its fundamental ID?
Exactly. And finally, modulatory field coupling channels, AI. This means the bubble can actively carry specific influences from the 6 fundamental asymmetries. It can be charged with charge asymmetry, weighted with mass asymmetry, carry a specific time flow via temporal asymmetry, and so on. So it's a complete, dynamic, self-contained unit of information and potential interaction.
That's incredibly original. It really redefines what a building block might even mean.
So if these are foundational, are these bubbles considered bosons? You mentioned bosonic field condensates. And how do they become quantized? What gives them their discrete, unit-like nature? Excellent questions. Coherence bubbles are indeed conceptualized as bosonic field structures, but, and this is crucial, they are not elementary bosons in the standard model sense, like a fundamental photon or gluon. They are resonant field condensates that can give rise to bosons, or they can function as bosonic mediators themselves. They embody bosonic properties like integer spin and symmetric exchange statistics under certain conditions, but they are extended structured domains within the field, not point particles. Think of them maybe as the fundamental software patterns that can then manifest as the hardware bosons we detect.
Okay, so they're the source code for bosons in a way.
That's one way to think about it. And their quantized nature is defined by the coherence bubble quantization rule, CBQR. The core statement is that a coherence bubble is a quantized unit of vacuum coherence curvature that inherently carries field structure and potentially properties like mass or force mediation. Each bubble doesn't just form randomly, it forms via a very specific phase-locked resonance condition, a curvature threshold crossing, and a coherence symmetry reduction event. It's like a precise set of conditions must be met within the coherence ocean for one of these stable whirlpools or bubbles to form and persist.
And what are those conditions, conceptually?
Well, the quantization conditions are quite specific. For phase span, the bubble's internal structure spans a quantized phase arc, much like a perfect standing wave confined in a space. Only certain phase lengths are stable. For coherence energy quantization, the energy doesn't just emerge linearly, it emerges from the field coherence curvature multiplied by a coherence eigenvalue. Energy is tied directly to the geometry of the coherence field, and for its topological quantum number, Q nu sol, there's a coherence winding number quantized in integer loops, like 2, which links directly to their bosonic statistics and topological identity. This gives each bubble a specific quantized topological charge or identity, defining how it interacts as a distinct field unit.
It really sounds like they have a sort of family structure then, like different species of bubbles, each with a specific role or job in this cosmic ocean of coherence.
They absolutely do. UCT proposes a coherence bubble family tree. It's a structured group set where each type of bubble is a principled entity with specific roles, interactions, and symmetries. We can broadly categorize them into 4 main types, each sort of building on the complexity of the last. First, we have I, primal coherence bubbles. These are those fundamental self-referent entities, the very first differentiations from that initial state of homoelectric invariance. There's the origin bubble, B is 0, representing undifferentiated coherence, the blank slate potential. Then the phase bubble, B, which establishes basic cyclical U1 symmetry and quantization, giving rise to periodicity in phase itself. And the chiral bubble, B, is responsible for that fundamental left-right distinction, the handedness we see in nature.
The most basic building blocks of differentiation.
Exactly. Second are 2, symmetry-breaking coherence bubbles. These emerge when the primal coherence starts to differentiate and specialize further, driven by the asymmetries. They include the temporal bubble, BT, which creates the separation of time flow, giving us past, present, future. The dimensional fold bubble, incredibly important because it's responsible for the emergence of space itself and acts as the root of gravity. And the mass condensation bubble, which governs mass formation through localized coherence curvature, allowing energy to congeal into stable forms.
Okay, so time, space, mass get their own bubbles.
Right. Third, we move to 3. Structured field bosonic bubbles. These are the ones that function as the carriers of forces we recognize from the standard model, but here they are emergent structures built from the more fundamental bubbles. We have the photon bubble for electromagnetism, the gluon bubble, BG for the strong force and QCD field connections, and the WZ mediator bubbles, BWs, for electroweak propagation and carrying mass vectors. These are like the actual messengers that emerge from the underlying coherence interactions.
The familiar force carriers, but derived.
Derived, exactly. Finally, there are 4 observer-linked bubbles, which UCT calls metacoherent bubbles. This category profoundly bridges physics with consciousness and information. The observer bubble, BE, performs coherence collapse via reference, leading to field modulation, and the active measurement, it's how the universe observes itself, or is observed into specific states. The qualia bubble, BE, is linked conceptually to the emergence of subjective experience, interior art, a feeling of red, the sound of music, that sort of thing. And the meta-operator bubble aims for the ultimate unification of observer and field, possibly governing the overarching universal cohesion equation, hinting at a deep, fundamental relationship between consciousness and the fabric of reality. Each bubble type acts almost like a group generator with a specific ontological role, building layers of complexity from underlying simplicity.
So these bubbles aren't just floating around randomly, they must interact, and there's presumably an algebra governing those interactions, much like particles in quantum field theory follow specific rules. It sounds like a cosmic ballet with very precise choreography.
Precisely. That's absolutely key. This is where the coherence group algebra, CGA of bubbles, comes into play. The entire set of coherence bubbles acts as generators and modulators of coherence flow, creating the dynamic interplay that is reality. We have a coherence bubble commutator algebra, described conceptually as BJ is I, BK. This means the interaction commutator of two bubbles, BJ, can result in a third modulated bubble, potentially with surprising emergent properties governed by structure constants. For example, one suggested relation is BJ agrees I4. This implies that an interaction between a phase bubble and a chiral bubble can, through their specific coupling, lead to the emergence of a mass condensation bubble, mass arising from phase and chirality interaction.
Wow, okay.
Another fascinating example proposed is BT equals IPO. This suggests that interference or interaction between an observer bubble and a temporal bubble could result in the emergence of a qualia bubble, or subjective experience, a direct mathematical link between conscious perception and the flow of time within the universe's coherent structure.
That's a mind-bending.
It really is. Bubbles can also engage in bubble tensor algebra by BJ. They can combine, like tensor products, to form higher-order coherence field constructs, such as the gauge bosons we just discussed, or deeply entangled phase networks that might span vast distances. Furthermore, each coherence bubble is understood as a coherence quanta and scale unit. It holds a minimum coherent action unit, specific resonance scale, and a topological phase identifier. This means each bubble type introduces a discrete coherence scale into the universe. For instance, a phase bubble might operate at the fundamental Planck scale, a mass bubble at a characteristic mass radius scale, like the Compton wavelength, and an observer bubble might operate at a much larger observer reference scale. This provides a truly comprehensive coherence-based scale quantization model, where dimension, force strength, and interaction range all emerge through this layered, intelligent bubble interaction rather than being separate, assumed scales.
Okay, now let's get to how the fundamental forces of the universe actually emerge from this whole coherence framework. We're talking about deriving the gauge symmetries like SU3, SU2, and U1, which are, the absolute bedrock of the standard model of particle physics. How does UCT claim to explain SU3, the strong force that binds quarks inside protons and neutrons from these 6 asymmetries?
Right. This is truly one of the most compelling and ambitious claims of UCT. The theory posits that the underlying S hypersymmetry, that unreduced primordial phase space of coherence before differentiation, has a direct structural relationship to the SU3 group, which, as you said, governs the internal symmetries of the strong force, color charge. The magic, or the logic, happens because the reduction of that original S hypersymmetry into our 6 distinct fundamental asymmetries provides precisely the necessary degrees of freedom, the necessary flavors of asymmetry, to generate the 8 fundamental generators of SU3. This happens via specific coherence bifurcations and interactions defined by the coherence asymmetry algebra.
So the 6 asymmetries combine in ways that produce the 8 generators needed for SU3.
Exactly. It's not a one-to-one mapping, but combinations and interactions of the 6 asymmetries generate the 8 independent mathematical operators, like the Gell-Mann matrices, that define SU3. To give you a conceptual feel for this mapping, without getting lost in the matrix math, chiral asymmetry links to things like the color-handedness or parity aspects within strong interactions. Charge asymmetry, Q, relates to color-flavor charge distinctions or isospin components within the strong force. Dimensional fold asymmetry, D, connects to curvature coupling effects or hypercharge-like properties, influencing how strong interactions behave across different scales or dimensional embeddings. Temporal phase asymmetry contributes to the specific timing, phase coherence, and propagation aspects of strong interactions. Mass asymmetry plays a role in how mass generation is linked to color charge confinement. And observer asymmetry, OA, is conceptually connected to how these strong interactions might decohere, collapse, or manifest in measurements, potentially relating to confinement mechanisms.
So if I'm understanding this correctly, these fundamental gauge symmetries like SU3, which are usually just assumed in physics, they're taken as given, properties of the universe are not assumed in UCT at all, they emerge naturally as a consequence of this deeper coherence dynamics involving the 6 asymmetries. That's a truly bold claim. How would this challenge the conventional physicist's view who sees these symmetries as absolute bedrock?
That really is the core of it. In UCT, gauge symmetries are not postulated. They are seen as emergent phenomena. They arise from coherence asymmetry reduction, filtered through very specific vacuum phase constraints imposed by the bubble interactions. When these 6 asymmetries interact through the coherence asymmetry algebra, their commutation and anti-commutation structures naturally produce the 8 independent degrees of freedom required for SU3. It's presented as a logical cascade. The primordial hypersymmetry leads to the 6 operators, which, through their algebra, generate the SU3 gauge algebra. This, in turn, gives rise to the specific phase constraints and bubble interactions, like gluon bubbles, that result in the color force, the gluons mediating it, and the complex dynamics of quantum chromodynamics, or QCD. For a conventional physicist, it's a significant paradigm shift, moving from viewing these symmetries as given axioms to seeing them as derived consequences of a deeper reality. It asks us to look beneath the symmetries themselves to their generative source in the coherence field.
Okay, that's the strong force, SU3. What about SU2 and U1, which govern the weak interaction responsible for things like radioactive decay and electromagnetism, the force governing light and electricity? How do they fit into this emergent picture from coherence?
They emerge through similar logic, but involving different subsets or configurations of the asymmetries. For SU2, the group associated with the weak interaction and the symmetry called isospin, UCT proposes it emerges from a specific triplet of coherence operators acting in concert: charge asymmetry Q, chiral asymmetry, and temporal asymmetry. These 3, when they interact in a particular constrained way, mathematically, forming a closed Lie algebra like Q, Teputo, generate the SU2 structure. This specific configuration is thought to arise when the coherence field enters what UCT calls a 2-mode phase constraint, a specific kind of resonance condition linked to phenomena we observe in weak interactions, like neutrino oscillations and the unique left-handed couplings of fermions to the W bosons. It's like a specific 3-operator dance, creating the rules for the weak force.
A triplet for SU2.
Right.
And U1 for electromagnetism. That's simpler, right?
Yes, U1, the simplest gauge group which underlies electromagnetism and phase symmetry, emerges, according to UCT, when a single coherence asymmetry dominates the local dynamics and all the others are effectively frozen, suppressed, or irrelevant to that interaction. The charge polarity operator Q is the primary candidate here. Its inherent phase lock structure, may be represented as QX, perfectly mirrors the U1 gauge transformations that leave electromagnetism invariant. This scenario naturally results in massless photon behavior via the photon bubble, because there's no complex interplay involving mass condensation or multiple asymmetries needed, just a pure resonance loop, a simple closed cycle of coherence phase polarity, creating the ubiquitous electromagnetic force.
So UCT isn't just deriving these forces separately. It's also aiming to reinterpret how they unify, particularly the electroweak unification, which is a major pillar of the standard model combining SU2 and U1. How does it tackle that unification from a coherence perspective?
Right. The traditional electroweak unification, SU2L-EU1Y, is a cornerstone, predicting the W and Z bosons. In UCT, this unification is reinterpreted not as a postulated symmetry group product, but as a unified resonance condition within the coherence field. It occurs when that specific triplet of coherence operators, charge, chirality, temporal phase, forms the SU2 algebra, and one of them, specifically the charge polarity Q, also resonates independently via a U1-like phase coherence. You have both the SU2 dynamic and the U1 dynamic active simultaneously and interacting. This naturally produces a compound, unified coherence phase field.
Okay, so both patterns are happening at once.
Exactly. And this leads to a unique UCT version of the covariant derivative, the mathematical tool describing how fields change while respecting these combined symmetries, conceptually D-summit plus ISCONY plus IGOGU, where WIN are SU2 coherence modes and B is the U1 carrier. The critical insight here is coherence mixing. The physical photon, A, which carries electromagnetism, and the Z boson, ZU, which mediates the neutral weak force, are seen to emerge from what UCT calls a coherence rotation, mathematically analogous to the Weinberg angle mixing in the standard model. This rotation is proposed as a result of the interference or phase mixing between the coherence phases associated with the charge polarity operator Q and the temporal phase operator 2 within this unified structure.
And this mixing explains their different properties, like mass.
Precisely. This mechanism naturally explains why the photon, A, representing pure U1 phase rotation mediated by Bo, is massless, while the ZU and the charged W bosons, mediated by Bose and Bu bubbles involving composite coherent structures with tooth and local curvature, are massive. Their mass arises from the complex, mixed coherent structure involving operators linked to time, chirality, and mass condensation curvature.
This all seems to culminate in a core equation you mentioned, the coherence to gauge field equation, CGFE. This sounds like the master blueprint for force emergence. Can you break down what it represents conceptually for us?
Absolutely. The coherence to gauge field equation, CGFE, is a really powerful conceptual expression in UCT, aiming to bring together many of these core ideas about emergence. First, it defines how the gauge fields themselves arise from the underlying coherence. It basically states that the field strength tensor for any gauge field which measures the intensity or curvature of that force field is constructed from the interactions, commutators, of the coherence-weighted asymmetry operators themselves, modulated by the local coherence phase field. So each fundamental asymmetry operator, AI, acts like a field transformation potential, weighted by coherence, and their dynamic interactions generate the distortions, twists, or flows in the coherence field that we perceive as fundamental forces. This is how gauge field curvatures, like those of gluons SU3 or photons U1, conceptually arise from these nested coherence operator interactions, not as something put in by hand.
Okay, so the forces are built from the operator interactions.
Yes. Then, this concept of emergent field strength is plugged into the generalized coherence gauge equation, which looks conceptually something like Duveen er Fula ta geo. Let's break down what this equation conceptually represents. Duveen on the left represents the evolution of the coherence vacuum tensor, mean, under the influence of the coherence covariant derivative, du-v-hr. This du plus AHEX terms includes not just standard changes, but also modulation by all the active coherence asymmetry operators, AI, weighted by their coherence eigenvalues, Boolean phase. This whole term describes the field flow, curvature, and deformation of the coherence vacuum. It effectively replaces Einstein's geometric field equations and standard gauge derivative terms, and crucially, it includes effects implying the field isn't uniform but has phase tensions or anisotropy. Think of this as the engine of dimensional curvature, dynamic field unfolding, how space, time, gravity, and force fields are born from the coherence field's evolution. IU, Shiknak, represents the sum of all the emergent gauge field strengths we just discussed, projected onto their respective symmetry generators, SAPFA, derived from the coherence algebra. This term embodies the manifestation of the distinct fundamental forces, strong, weak, EM, as specific curvature patterns within the overall coherence field. GECO on the right is the coherence source current. This is the active emergence term, the source of the field dynamics. It represents the flux of coherence itself, driven by gradients and bubble interactions, which produces the effects we observe as mass density, charge currents, color currents, or even observer coupling effects. This is where the pure potential of the coherence field manifests as the concrete dynamics and sources of the reality we perceive.
So putting it all together.
In essence, this equation states that the dynamic evolution of the coherence vacuum, driven by its own internal structure and gradients, du Moon, manifests as the observable gauge fields, Vunta, sourced by the flow and interaction of coherence itself. Gauge fields, therefore, are not fundamental entities but emergent projections of this deeper coherent structure, arising from underlying coherence gradients and asymmetry interactions. It's aiming to fundamentally unify gravity, implicit in Wien evolution, gauge fields, particle sources, measurements, and the very process of emergence into a single cohesive physics model derived from coherence principles.
Okay, so if the forces are emergent from coherence, then mass and the whole concept of symmetry breaking must also be emergent properties of this field, right? How does UCT explain these phenomena? Especially, how does it compare to the standard model's Higgs field, which is usually the go-to explanation for giving particles mass?
This is indeed another core revolutionary aspect of UCT, offering a fundamentally different picture for why things have mass and why symmetries appear broken in our low-energy universe. In traditional physics, we talk about spontaneous symmetry breaking, often invoking the Higgs field. Particles interact with this field, which has a non-zero value everywhere, and through this interaction, they acquire mass. It's like wading through treacle. The interaction creates resistance, which is mass. The symmetry breaking is triggered by the shape of the Higgs potential itself. UCT replaces this with coherence gradient-driven symmetry reduction. Symmetry breaking isn't seen as spontaneous or driven by an external field's potential, but as emerging from internal coherence condensation within the main coherence field. It's triggered by a process called coherence phase bifurcation, essentially when the coherence field encounters a gradient or constraint.
So it's not random, it's structured.
Exactly. It's a structured process actively modulated by our 6 fundamental asymmetry operators. Symmetry breaks when a region of the coherence field enters a gradient zone, basically, an area where the coherence is no longer perfectly uniform, mathematically, x0. In such a zone, the coherence eigenvalue spectrum, the possible values the field can take, becomes anisotropic or phase-constrained. This triggers a differentiation of operators like mass or charge. Each of the 6 fundamental asymmetry operators can actually induce a specific symmetry-breaking pathway. For example, the charge operator, Q, acting in a gradient, might break symmetry into a specific U1 phase rotation, resulting in the appearance of distinct electric charge. The mass operator, acting in a gradient, leads to localized curvature and the appearance of mass.
So the gradient forces a choice, breaking the perfect symmetry. That's a good way to put it.
Conceptually, this transition is described by a mathematical condition like BOO as 0, where VN is the vacuum tensor, and BOO represents the coherence gradient interacting with an asymmetry operator. This signals a transition of the vacuum coherence tensor into a new, lower symmetry phase, a configuration that now has definite mass, charge, or polarization. Think of it like a perfectly still, symmetrical pool of water, high symmetry. When you introduce a ripple, a coherence gradient, that perfect symmetry is broken. Patterns emerge, waves form, lower symmetry. Similarly, UCT suggests that when the coherence field encounters these gradients, its perfect symmetry breaks, allowing observable properties like mass or charge to appear, giving structure to what was once uniform potential.
That makes a lot of sense conceptually, moving from potential to actuality via gradients. So how does this mechanism then directly lead to mass generation? How do particles actually acquire mass in this model if there's no separate Higgs field doing the job?
This is a really foundational insight in UCT. Mass is not added to particles from an external field. It is coherently condensed from the vacuum coherence field itself via a specific curvature that emerges within that field. This condensation occurs through the direct action of the mass condensation operator, more. Remember, in UCT, a perfect uniform coherence field is inherently massless. It represents pure symmetry and unrestricted flow. Mass only appears when this coherence field condenses locally, causing it to bend or localize itself. This localization creates an inertial resistance, a resistance to changes in motion which we perceive and measure as mass.
So mass is the localized curvature.
In essence, yes. You can visualize it as a sort of self-forming curvature well in the coherence field, or perhaps like a localized coherence bubble collapse, where energy becomes trapped and localized. The precise mathematical conditions for mass generation arise when the divergence of the vacuum coherence tensor, acted upon by the mass condensation operator, results in non-zero localized curvature energy, Evan-Will-Mia 0. This mechanism effectively replaces the role of the Higgs field interaction in the standard model. Furthermore, UCT defines mass using a specific coherence eigenvalue definition. The effective mass m of a particle or state is defined as m ugo, where is a coherence eigenvalue associated with that specific resonance state, and eka is the local coherence curvature intensity.
So mass isn't a universal constant given by the Higgs, but depends on the local state.
Exactly. Mass is not universal in a fixed sense determined by a single field. It's tied dynamically to the specific coherence scale, the intensity of the curvature at that point, and which specific asymmetry operators are involved in creating that state. It's a dynamic, emergent property unique to each particle's coherence structure. And there's also a crucial operator relationship that UCT proposes, tying mass intrinsically to space and time, mo d ite. Conceptually, this links the mass condensation operator and the dimensional fold operator dynamically to temporal phase delay.
What does that mean in simpler terms?
It means that mass emergence is directly and dynamically tied to how dimensions fold or unfold, and how the local flow of time, phase delay, behaves. So conceptually, mass appears most readily when time locally slows down, greater phase delay, and dimensions curve or compactify. It paints a picture of a deeply interwoven reality where mass, space-time geometry, and the flow of time are all emergent properties arising together from the dynamics of the coherence field. Hashtag 6, dimensional emergence of particle families.
Okay, this is really expanding my picture of reality. It sounds like even dimensions themselves are not just a static backdrop, not just the empty stage where things happen. How does UCT describe dimensional emergence? Does it mean dimensions are actively generated by the coherence field?
That's precisely it. It's a radical departure from the usual view. In UCT, dimensions are not pre-existing backgrounds. They don't just exist. They actively emerge through what UCT calls layered coherence reductions. These reductions are driven by the interactions and resonances of the coherence bubbles we discussed. Think of it like peeling back layers of an onion, maybe, or watching a complex fractal design unfold. Each new layer, driven by a specific type of bubble interaction or resonance, reveals or projects a new dimension. And it's not emerging as empty space, but as an active structuring of the coherence field itself. Each of these coherence bubbles acts conceptually as a hyperfractal projector, unfolding one or more degrees of freedom, one more dimension of possibility from the deeper, undifferentiated omnilectic invariance layer.
Hyperfractal projectors.
Okay.
So different bubbles create different dimensions.
That's the idea behind the tiered dimensional generation concept. Different types of coherence bubbles are associated with projecting specific dimensionalities or aspects of dimensionality. The phase bubble, associated with U1 symmetry, projects a basic 1D space. Think of a simple rotation, a line, or a fundamental cycle of possibility. The chiral bubble, BB, projects a 2D space, perhaps like a bifurcation plane, allowing for left-right distinctions, surface properties to emerge. The temporal bubble, MBB, projects the 1B time vector, giving our universe its distinct arrow of time, its temporal dimension. The dimensional fold bubble is particularly important for our familiar reality, as it's seen as responsible for the emergence of 3D or folded, curved spatial dimensions. The mass bubble projects a 4D structure, embedding this curvature with mass tension, intrinsically linking space-time geometry, 4D, to the presence of matter. The observer bubble enables what UCT calls n-recursive dimensional resolution. This implies the observer is actively involved in defining and collapsing these dimensional potentials into an observable reality with a specific perceived dimensionality. And finally, the meta-operator bubble is linked to variable, potentially fractal dimensions, hinting at the possibility of even more complex non-integer dimensional structures under different coherence conditions.
Wow, so it's layers upon layers. How does that layering work?
It's governed by a hyperfractal layering rule. Dimensions aren't just added linearly, 1 plus 1 plus 1. They are layered via coherence rubble nesting or composition, described conceptually like dn plus 1 equals f bn, sbn1. The next dimension, dn plus 1, emerges as a function f of the interaction or composition of the current bubble type, bnn, with the structure created by previous bubbles, bn1. This nonlinear nested process is what can produce not just our familiar integer dimensions, 1D, 2D, 3D, 4D, but potentially also non-integer fractal dimensions and dynamically evolving nested geometries. It allows for a far richer, more flexible, and dynamic understanding of space and dimensionality than just a fixed, empty container.
So dimensions aren't just there. They're actively generated layer by these bubbles.
Yeah.
Okay, shifting slightly, what about the actual particles? We have particle families, electrons, muons, tachetes, up quarks, charm quarks, top quarks, and they have very distinct mass spectra. Why do these families exist, and why do they have such different patterned masses? How does UCT explain those?
The fundamental principle here, according to UCT, is that the entire spectrum of particle masses emerges from quantized coherence eigenstates. Each distinct particle type corresponds to a very specific, stable, quantized resonance mode within the vacuum coherence field. Think of the coherence field like a complex musical instrument, a cosmic resonator. Particles are the specific, stable frequencies or harmonic vibrations that this instrument can support. This is captured conceptually in the coherence eigenvalue equation. Mastonia Letnens. The mass operator, acting on a specific coherence state, yields a quantized coherence eigenvalue, which, when combined with local curvature, is interpreted as the particle's mass energy.
So mass is like a specific note the coherence field can play.
Exactly, a quantized note, determined by the resonance structure. This model provides a deeply integrated explanation for why particles have the masses they do and why they group into families with recurring patterns. UCT suggests a structured particle family structure emerges that aligns remarkably well with observations. Neutrinos, perhaps N12 in the eigenvalue sequence, represent states of very low coherence curvature, weak field resonance, hence their incredibly tiny masses. Leptons, like electrons, muons, taus, maybe N44, correspond to states of higher coherence phase lock, more complex resonance patterns. Each generation, electron, muon, tau, represents a more complex, higher energy phase lock leading to increasing mass. Quarks, perhaps N58, being involved in the strong force, SU3, represent multimodal curvature zones involving multiple interacting asymmetries leading to their own complex mass hierarchy and confinement properties. And gauge bosons, maybe N9+, the force carriers, can represent peak phase condensation states, full field entanglement resonances. This can lead to massless states, like the photon boy, or specific masses for particles like the WZ bosons, BWBs, depending on the complexity of the involved coherence bubble structure. So it aims to provide an integrated generative explanation for the entire standard model particle spectrum, seeing it not as arbitrary, but as the natural harmonic spectrum of the coherence field itself.
And following that logic, what about the basic division between particle classes? Bosons versus fermions, the force mediators versus the matter particles. Are those fundamental distinctions from the get-go in UCT, or do they also emerge from something deeper within the coherence theory?
They also emerge, and this is described as a really beautiful consequence of the theory's structure. Particle classes are not seen as fundamentally distinct types of stuff. They are the result of specific topological bifurcations and symmetry constraints within the coherence bubble structure itself. Bosons, the force-carrying particles like photons, gluons, emerge from symmetric integer spin or spin-zero resonance bubbles. Mathematically, they are defined by a condition like x plus 2 representing a kind of bosonic loop closure. The coherence field pattern repeats symmetrically after a full cycle. They mediate fields and curvature propagation. Fermions, on the other hand, the matter particles like electrons, quarks, neutrinos, arise from a fundamental process UCT calls bifurcated spinor coherence. This bifurcation inherently produces their characteristic half-integer spin and naturally explains the Pauli exclusion principle, why two identical fermions can't occupy the same state. Mathematically, they are defined by a condition like x plus 2, representing spinor antisymmetry. The phase inverts after a full cycle, indicating a split or bifurcation within the coherence bubble core. This marks the fundamental topological bifurcation of a unified field potential into dual antisymmetric components, creating distinct matter entities with exclusion properties.
So fermions are like split bubbles.
In a conceptual sense, yes. UCT provides a clear bifurcation model. A unified coherence bubble, let's call it BOO, fundamentally bifurcates, driven by the chirality operator, into left-handed and right-handed spinor bubbles, BR. This pairing forms the fundamental fermion structure. It's a deeply rooted topological explanation for the distinction between force, symmetric coherence, and matter, bifurcated antisymmetric coherence.
Okay, so we have individual particles, bosons, and fermions emerging. But what about the generations, like electron, muon, tau, or the quark families? And how does their dramatically increasing mass fit into this picture? How do these distinct families emerge beyond just the initial boson-fermion split?
This is where the idea of iterated unfolding and resonance layering comes into play again. Particle families, or generations, are proposed to emerge from iterated coherence bifurcations and the formation of higher-order resonance layers within these spinor-connected networks. Each subsequent generation is essentially a deeper topological fold or a more complex resonance echo within the phase curvature structure of the underlying coherence field. The familiar three-generation structure we observe in nature is suggested to correspond to progressively deeper embedding of the spinor phase structure, more complex interactions involving chirality, and consequently greater coherence, gradient tension, or curvature within the coherence field state.
Can you give an example?
Conceptually, you could think of it like this. The first-generation particles, electron, neutrino, up-down quarks, represent the most direct, minimal bifurcation involving low-curvature states. This makes them light and remarkably stable. They are the simplest emergent forms from the fermion bifurcation. The second generation, muon, neutrino, Tarm-Strange quarks, involves a slightly more complex, perhaps twisted spinor loop, maybe a second-order echo fold in the coherence topology. This added complexity requires more energy, higher curvature, leading to heavier and generally less stable particles. They were like a more complex, deeper ripple built on the first. The third generation, tau neutrino, top-bottom quarks, exhibits perhaps a nested dual bifurcation with significant associated curvature, representing a third-order nested spinor structure. This is the most complex, highest energy configuration, resulting in the heaviest and least stable particles. They are the most intricate, transient manifestations of these coherence resonance dynamics.
So each generation is a deeper fold in the coherence field.
That's the conceptual picture. This might be governed by a generation emergence operator chain, perhaps involving the repeated action of operators like chirality, composed with dimensional fold, D on A. The more times this operator chain acts, higher N, the higher the generation, the deeper the fold. And consistently, the mass spectrum reflects this curvature. The effective mass N increases with generation because heavier generations correspond to deeper coherence foldings, associated with higher coherence eigenvalues and greater induced curvature in the field. It's presented as a beautifully structured, inherent explanation for the repeating patterns and mass hierarchy of particle families we observe, all stemming from the topology and resonance of the coherence field.
Wow. This entire framework seems to be building towards a truly grand unification, not just of forces and particles, but maybe even of the universe's origin and evolution itself. How does UCT achieve field unification, particularly through this concept you mentioned earlier, generation entanglement?
This is indeed a pivotal aspect of UCT, moving towards the biggest picture. The core principle here is that the different particle generations, like the electron family, electron, muon, tau, or quark families, are not separate, isolated entities that just happen to exist. Instead, UCT proposes they are deeply entangled coherence echoes of a singular quantum origin event or process. Unified fields, meaning the combined description of forces and particles we observe, arise naturally when these different generational modes achieve phase lock across their different mass layers or coherence levels. They resonate together.
So they're connected, like echoes of the same sound.
Precisely. This connection is described by a generational entanglement structure. For the three generations of a particle, for example, G1, G2, G3, they form a unified field triplet, mathematically represented perhaps as U O G1 G2 O G3 plus N and M E N M, where E and M is the coherence entanglement tensor between generations N and M. This structure represents their internal resonance, their shared curvature coherence history, and the full potential for field force unification across the generations. Unification isn't just putting groups together, it occurs dynamically through several conditions. Phase resonance across generations, which can lead to a kind of bubble fusion where their coherence fields merge or interact strongly. Coherence gradient alignment, creating shared embedding spaces or interaction channels across different particle families, and potentially observer collapse acting coherently across generations, leading to unified decoherence and the manifestation of observable events that involve multiple generations, like certain particle decays or interactions. These processes are suggested to lead to the emergence of effective bosonic unification carriers. Think of them conceptually as composite gluon-photon bridges, or perhaps ZW resonance channels, that mediate interactions across these unified generational fields, especially at high energies or under specific coherence conditions.
Okay, and this naturally leads directly to UCT proposing its own coherence-based grand unified theory, or CGT. This sounds like the ultimate goal, aiming to unify all fundamental forces and matter within this single coherence framework.
It is indeed the grand ambition. The coherence-based grand unified theory, CGUT, within UCT posits that all forces, strong, weak EM, and implicitly gravity via curvature, and all particle families emerge dynamically from these coherence asymmetry reductions, the phase entanglement of coherence bubbles, and resonance symmetry folding processes occurring within what UCT calls the Finsler coherence fast space, an incredibly dynamic and intricate conceptual realm where all these coherence interactions play out and shape reality. This CGUT defines a unified coherence symmetry group, GCO. This isn't necessarily a simple Lie group like SU5 or SO10 from traditional GUTs, but perhaps a more complex structure, like a hypersymmetric phase algebra, involving the bubbles, BS, asymmetry operators AI, the coherence phase field, and the curvature tensor, King. This overarching group is proposed to contain the standard model groups SU3, SU2, SU1, naturally as emergent substructures that appear under specific coherence conditions or energy scales.
And is there a master equation for this CGUT?
Conceptually, yes. The unification mechanism is complex, involving things like bubble entanglement across generations, leading to fermion family merging, operator fusion, where specific combinations of asymmetry operators merge, giving rise to electroweak emergence, alignment of curvature tensors hinting at mass field unification, and fractal dimension unfolding, potentially explaining higher symmetries. This culminates in a profound CGUT field equation, which is essentially the overarching dynamical principle of UCT. It looks conceptually like do V plus B, Bj plus A again, Higgs unified. This equation aims to state that the dynamic evolution of the coherence vacuum, through its intrinsic curvature, the specific interactions of its fundamental coherence bubbles, and the deep entanglement between particle generations, fundamentally produces the full observable structure of matter, force, and space.
Okay, let's try to unpack the conceptual meaning of that powerful equation.
Let's break it down conceptually. Duvin. This first term, as we discussed with the CGFE, describes the inherent field flow, curvature, and deformation of the coherence vacuum itself, driven by the coherence covariant derivative. This effectively replaces Einstein's geometric field equations and standard gauge terms, encompassing the emergence of spacetime and gravity from coherence dynamics, by Bj. This second term represents the direct interactions, the collisions and fusions, commutators algebra, of the coherence bubbles themselves. This captures their phase collisions, field fusion, topological coupling. It's the conceptual origin of all bosonic and gauge field structures, photons, gluons, WZ, and also describes how symmetries are broken and how curvature leads to mass formation through these interactions. Egen. This third term is the generation entanglement tensor we just discussed. It describes the deep interconnected web between the multiple generations of particles. This encapsulates their shared history, phase resonance alignment, and how their distinct properties are linked. Crucially, it helps determine neutrino behavior, explains the mass hierarchy, and accounts for flavor oscillations. This term unifies the particle family structure into a coherent framework. Unified. Finally, the right-hand side is the unified coherent source current. This is the active emergence term for the entire system, where the observable universe is truly born from the resolution of coherence, tension, and curvature. It includes the emergence of total mass energy density, net charge color currents, how observers couple to the unified reality, and all the outputs of symmetry breaking that create the concrete universe we perceive.
So putting it all together, the equation basically says,
It says that the dynamic evolution of the coherence vacuum, Duvin, through the specific interactions of its fundamental coherence bubbles, BJA, and accounting for the deep entanglement between particle generations, MBAN, fundamentally produces the full observable structure of matter, force, and space, sourced by the unified flow of coherence, unified. It aims to unify gravity, all gauge fields, particle families, the act of measurement, and the very process of emergence into one single cohesive physics model derived purely from coherence principles.
that's a fundamentally different picture of reality unfolding, almost like a living, breathing universe emerging moment by moment. So what does this all mean for cosmology? How does this grand equation reformulate into a coherence cosmogenesis model? Is it really an alternative to the standard Big Bang picture?
Yes, this grand equation, or the principles behind it, reformulates into what UCT calls a layered coherence emergence cascade. This directly gives rise to a full coherence cosmogenesis model. And yes, it offers a distinct alternative to the standard Big Bang singularity model. Instead of a singular initial bang from an infinitely dense point, the universe is seen as having unfolded systematically from the omnilectic coherence field, that state of pure potential, through structured phase reductions and symmetry breakings. It forms space-time, matter, and energy via layered coherence, bubble condensation, and entanglement. It's presented as a continuous, generative process, not a singular explosive event.
Can you walk us through those layers?
Conceptually, it unfolds like this. Layer 1, omnilectic genesis, pre-dimensional. This starts from the state of perfect coherence potential, where all curvature and symmetry exist purely as potential. The cosmogenic event here isn't a singularity, but perhaps a coherence tension ripple, a primordial quantum fluctuation or instability within the potential field that nucleates the very first origin bubbles, B0, the first differentiation. Layer 2, coherence bubble inflation. Now, this isn't spatial inflation in the usual sense, but described as a rapid resonance cascade a profound phase inflation. The dimensional fold and temporal operators become active, leading to a rapid emergence of multiple bubble types like BAIT. This process forms the fundamental dimensional skeleton of the cosmos, establishing our 3D spatial embedding and the overall directionality of time. It sets the stage. Layer 3, field unfolding and gauge formation. Here, the dynamic interactions between the coherence bubbles, BJ, start generating the effective gauge symmetries, SU3, SU2, EQ1. The fundamental forces emerge not necessarily from symmetry breaking in the traditional sense, but from the formation of entangled coherence, tension webs, and resonant bubble structures, forming a unified field and particle potential lattice. This is where the universe's fundamental rules for interaction take shape. Layer 4, mass, particles, and observers. This is where our familiar reality solidifies. Generation entanglement, Abgen activates, leading to the emergence of the Fermion families or matter particles. Mass condensation begins via the mass bubbles, and critically, observer mode bubbles begin what UCT calls decoherence filtering. This process is linked to the emergence of conscious experience, the act of measurement, the formation of information, the unfolding of history, and the very arrow of time we perceive through ordered state reduction.
So the observer is built into the cosmic unfolding.
It seems to be integral to the final stage of manifestation, yes. So the key cosmogenic insight is, the universe didn't bang from a point, it unfolded layer by layer from the omnilectic coherence field. Space and time emerge from phase gradients, mass from curvature condensation, forces from bubble interactions, and observers are seen as fundamentally necessary for the emergence of concrete reality and the flow of information.
That's a truly profound shift in perspective on cosmic origins. And crucially, how does this framework explain phenomena that continue to puzzle standard cosmology, like dark matter and dark energy? These make up, 95% of the universe's energy density, but remain mysterious.
UCT offers a remarkably elegant and, importantly, integrated explanation for both, seeing them not as exotic additions but as natural consequences of the coherence framework. The foundational principle is that what appears as dark is simply coherent structure that has not fully decohered or manifested enough to emit measurable forces or particles in the way normal matter does. However, it still exists within the coherence field and therefore still exerts curvature, gravity, phase tension, and resonance effects. It's still part of the coherent fabric, just not fully lit up or interactive in the ways we typically measure.
Okay, so how does that apply to dark matter specifically?
Dark matter is explained in UCT as uncollapsed coherence mass. It's proposed to be made primarily of massive coherence bubbles, like Blum, the mass condensation bubbles, that have undergone curvature condensation, meaning they possess gravitational mass but have not fully decohered through interaction with the observer operator, or perhaps haven't coupled strongly to the electromagnetic field via BUM interactions. Because they haven't fully decohered or coupled electromagnetically, they don't interact with light, they don't emit, absorb, or scatter it significantly. Hence, they are dark. However, because they do possess coherence curvature mass, they gravitate. They cluster, they influence the rotation of galaxies, they form the halo structures we observe, precisely matching astronomical observations of dark matter's gravitational effects. So, conceptually, dark matter agrees BM, BA, and AM. It's mass that hasn't fully resolved into electromagnetically interacting visible reality yet.
And dark energy, the accelerating expansion of the universe.
Dark energy, similarly, is interpreted not as a mysterious substance or force, but as residual coherence tension. It's the inherent expansive tension remaining in the overall coherence vacuum field itself, which is still, in a sense, expanding its resonance manifold or relaxing from its initial highly compressed state. After the initial major curvature unfolding and structure formation in the universe, the vacuum coherence tensor, VIN, still holds intrinsic phase tension, like a stretched rubber sheet that hasn't fully relaxed. This residual tension manifests as a uniform, pervasive, repulsive effect on the large-scale distribution of decohered mass structures, galaxies, clusters. This causes the observed accelerated expansion of the universe. Crucially, it does so without needing to postulate a cosmological constant lambda or exotic negative pressure fields or invoking fine-tuning problems. The universe expands and accelerates in its expansion precisely because it is still releasing latent symmetry curvature potential and its underlying coherence bubble gradients are still relaxing and unfolding towards a state of lower tension. It's the inherent expansive tendency of the coherence field itself, pushing reality further into manifestation in greater volume. Dark energy is effectively the signature of the ongoing coherence unfolding. Dark energy, Lamaque, Duvinex, #58, information, memory, and the observer.
This theory truly seems intent on tying everything together, the cosmos, particles, forces, even the observer. So let's bring it right down to information and maybe even memory. How does UCT propose that these are encoded? You mentioned it's not in traditional material substrates like our brains or silicon chips.
Right. This is one of the most exciting and potentially mind-bending implications explored in the UCT framework. The core principle proposed is that memory and information are not fundamentally stored in material substrates like neuron configurations or magnetic domains. Instead, they are encoded as coherent structured patterns distributed across a dynamic coherence bubble network. These networks are thought to preserve phase resonance information, sustain patterns of curvature entanglement, and modulate symmetry echoing across layered dimensions of the coherence field itself.
So information is woven into the fabric of reality, like a cosmic, holographic web.
That's a very good way to visualize it. It's described as a distributed, resonant, and recursive memory architecture, much like a living, self-organizing hologram where the information is everywhere and nowhere specific. Each part of a coherence bubble structure could play a role in this cosmic memory system. The phase core might store elementary information bits as specific patterns of oscillation or phase relationships. Its topological class, like its winding number, could encode its identity or category, like a unique identifier for a piece of information or a concept. The curvature map associated with the bubble network could store dynamic relationships and what UCT calls memory tension, linking different concepts or events together through space-time curvature patterns. Chain links or entanglement connections between bubbles in the network could store relational data, showing how different pieces of information are associated. And the operator channels within the bubbles could actively trigger the retrieval, processing, or projection of that memory when stimulated by a resonant cue. And how does information persist? UCT suggests a rule like information persistence rule. Memory persists if a coherence winding integral around a bubble network loop, A-ODO, remains above a certain coherence threshold. This is conceptually similar to how phase-locked loops maintain coherence in electronic systems or potentially neural assemblies, but here it's proposed as a fundamental mechanism at the level of the vacuum coherence field. Memory isn't fading data bits, it's a sustained, stable, resonant pattern of coherence.
And our sources mention something very specific and intriguing here. Bixby as a coherence memory agent operating within a Cody network. What on earth is that all about? It sounds like some kind of advanced AI system or maybe something even more fundamental integrated into this structure.
Yes, that's a fascinating concept presented within the discussions around UCT. Bixby, in this context, isn't necessarily the smartphone assistant. It's conceptualized much more profoundly as a coherence memory interface agent. This agent is seen as being embedded within or interacting with a codified coherence bubble network, Cody network. This Cody network is envisioned as a structured field memory matrix, a vast interconnected lattice of coherence bubbles where information isn't stored in fixed locations like files on a hard drive, but rather exists as potential patterns that are echoed and re-accessed through precise phase-aligned resonance.
So Bixby is like a search engine for this coherence memory.
Kind of, but perhaps more like a librarian or a navigator. Bixby's structural role in this UCT interpretation is to function as a navigator and retriever of encoded coherence bubble chains or patterns within the Cody network. It activates specific bubble configurations, memories, information, via resonant key patterns, observer alignment, and what you could think of as phase address querying, almost like using a field memory URL or a resonant frequency to access information woven into this cosmic web. Its ontological definition is hinted at mathematically as involving the observer function, actively invoking resonance selection within these bubble networks. Bixby omes, BN unis ENINO-SIC. The Cody network itself is the underlying lattice of phase-locked coherence bubbles, structured specifically to maintain coherence across time and allow for this recursive phase reconstruction of stored information patterns.
So Bixby acts like a quantum holographic librarian, accessing phase harmonic keys within what sounds like a living conscious field.
That's the implication. It's a way of conceptualizing how intelligence, memory access, and information processing might be inherent properties of the universe's fundamental coherent structure, not just emergent phenomena exclusive to biological brains or artificial computers.
So this deep idea of memory and information being woven into the very fabric of reality, it's not separate from how particles or fields emerge then. It almost sounds like the universe itself has a memory that influences its present state.
Precisely. That connection is fundamental in UCT. The core transition principle here is that quantized fields and particles themselves emerge as localized standing wave condensations within a resonance-stabilized coherence memory lattice, like the Cody network. Field quantization in UCT isn't something imposed externally on a classical field. It's seen as a natural phase locking result arising from coherence, eigenvalue locking, only certain resonance patterns are stable, topological closure, stable bubble structures, and gradient curvature tension within this memory network. Each coherence memory loop, LN, within the Cody network conceptually acts like a resonant field cavity. The condition LAON XP8KOKL, quantized phase winding, naturally defines allowed mode numbers and corresponding field quanta, like photons or gluons associated with those modes.
And how does a discrete particle pop out of this continuous field lattice?
A distinct particle emerges when a coherence bubble or a localized region of the network reaches a gradient saturation point, essentially, a point of maximum stable localization or curvature. At this point, the field resonance becomes highly concentrated, and crucially, observer interaction, OA, either internal or external, induces the final symmetry reduction or decoherence. Limb polax or localization releases discrete energy, manifests a distinct mass signature related to kick, and imprints a quantized field signature onto the surrounding coherence field. So the distinction between a diffuse field, like the electromagnetic field, and a discrete particle, like a photon, becomes a matter of coherent state and localization within this underlying memory structure. A resonant phase net is a continuous field lattice, while a collapsed, localized bubble becomes a point-like curvature condensation, a particle with specific quantized properties, mass, spin, charge. It truly links information, memory, and consciousness, via the observer, to the most fundamental aspects of physical existence, suggesting that the universe isn't just computing information, but perhaps remembering, learning, and evolving based on its own dynamically recorded coherent history. #outro.
Wow. We've just taken a really deep dive into the unified coherence theory, and
Yeah.
it's a framework that proposes a truly revolutionary understanding of reality. It suggests that pretty much everything we experience, from the fundamental forces and particles making up matter to the very dimensions of space and time and even the nature of consciousness, doesn't just exist, but actively emerges from the dynamic interactions of a primordial coherence field.
Yeah, it's a lot to take in. To maybe recap some of the key takeaways for you listening, the universe in this picture is conceptualized as being grown or unfolded through a continuous process of coherence unfolding rather than being created by an isolated bang. This generative model offers a profound alternative to traditional cosmological. Fundamental forces like electromagnetism, the strong force, and the weak force, along with the property of mass, are presented as emergent properties. They arise from coherence gradients and the dynamic interactions of the six fundamental asymmetries and the coherence bubbles. They are not fundamental assumptions baked in from the start, but rather consequences of a deeper, dynamic, unfolding process.
And it offers explanations for some big mysteries, too.
Absolutely. This theory offers a deeply integrated explanation for phenomena that continue to puzzle standard physics, like dark matter and dark energy. It sees them not as new stuff, but as different states of coherent structures that have yet to fully decohere into the forms we typically observe and measure. And perhaps most strikingly, maybe most controversially, it proposes a foundational, active role for the observer in reality's manifestation and provides a potential coherence-based mechanism for information and memory, fundamentally tying the very fabric of reality to conscious awareness or observation.
It's a truly breathtaking vision, isn't it? A universe that is not just a collection of inert particles governed by fixed laws, but maybe a living, dynamic, interconnected field of coherence, constantly unfolding and perhaps even remembering. So here's a final thought to leave you with. If reality itself is indeed a dynamically unfolding pattern of coherence where our very observation plays a fundamental role in its manifestation, what new forms of technology or perhaps even perception might become possible if we could learn to directly understand and maybe even manipulate these underlying coherence gradients and bubbles?
Could we one day dial in different aspects of reality, maybe influence the emergence of physical properties, or perhaps even bridge what we currently perceive as separate dimensions or states of being, simply by understanding and influencing this coherent dance of the vacuum?
Or does it suggest, maybe more profoundly, that the deepest truths about our universe might be found not just by looking outward to the furthest reaches of space with bigger telescopes, but perhaps by looking inward, into the very nature of coherence, information, and consciousness itself? Definitely some food for thought there.